Okay, so in this problem we have a steel rivet that is too big to fit in the hole that it's supposed to go in. So the idea is to put it in dry ice. So it's gonna shrink, it's gonna cool down, so it's gonna shrink, and it's gonna fit in the hole. So the data that we have for the problem is, first of all, before doing anything at ambient temperature, the rivet has diameter of 1.872 centimeters, which is that in meters. The size of the hole is 1.87 centimeters, which is 0.087 meters. So we want to take the rivet from room temperature, where it is this size, and room temperature is 22 degrees Celsius, to temperature of dry ice, which we don't know, and would make it become that size to fit in the hole. So this is a problem of linear thermal expansion. First of all, it's thermal expansion. It's linear because it's one dimension, one dimension that is changing. So we need to use the equation for linear thermal expansion. Which is that. So if you look at this equation, there's only one thing that we're missing, and this is alpha, the coefficient of linear expansion. So for steel, we can find in the table in the book that alpha is 12 times 10 to the minus 6 degrees Celsius inverse. So now we have everything we need to use this equation. So if you expand the equation, you find that delta L equals L minus L0. And delta T is T minus T0, so the change in temperature and the change in distance. We have all the information that we need except T, and this is what we want to get. So we can just isolate T here by dividing by alpha and L0. So L minus L0 divided by alpha L0 equals T minus T0. And we can just isolate T from there. And get this equation. We can plug in the numbers that we already have. We have 22 degrees plus 0.087 minus 0.0182 divided by 12 times 10 to the minus 6 times L0, which is 0.01872. So plugging in the numbers, we get 22 minus 89. And this is minus 67 degrees Celsius. So there's two things to see from this. First of all, minus 67 is cold, as we expected from dry ice. And this comes from the minus 89 in the equation, which comes from the fact that L is smaller than L0. So it means that we need to decrease the temperature. And of course, that's what we expected. So the answer is that the dry ice must be at minus 67 degrees Celsius for the rivet to fit in the hole.